Welcome to the special topic, SQL Server Installation and Setup Best Practices. In this lecture, we're going to talk about the best practices that is recommended to be followed when installing SQL Server and about some configuration steps you need to take right after you install SQL Server. So prior to installing SQL Server, you have the phase of planning and preparation of the upcoming SQL Server installation. During this process, you need to estimate the computational resources to be allocated to this SQL Server installation infrastructure. So you need to decide about the CPUs and the logical cores to be used, the amount of RAM to be allocated, and you need to make sure that you are allocating an adequate amount of CPUs and RAM based on the estimated workload to be processed by SQL Server. Another step within the planning and preparation phase is storage. So you need to provision an adequate amount of disk space. The best practice here is to make sure that you plan for the right disk capacity for your data, logs, backups, and TempDB files. We're going to talk more about this best practice later when we will be discussing the installation phase of SQL Server. Another recommendation is to use the proper allocation unit size for your drives. As a best practice, usually a 64 KB allocation unit size is used for data, logs, and TempDB file drives. Of course, this is something that you need to check in case you will be hosting a more sophisticated type of data in your SQL Server instance, for example, very large files and so on. So you need to take this into consideration as well. Last, you need to benchmark your drives with disk SPD. You can find this utility on GitHub by following the below link, and via this utility, which actually replaced the SQL I/O tool, you can benchmark your drives and see the throughput that you can get with these drives. Now, regarding the installation process, first you are presented with the feature selection. So first you need to select the features for your instance. So here you can select database engine services, replication, full text search, and so on. Also, you are presented with shared features options, for example, client tools connectivity, integration services, etc. Last, you need to configure the paths, and these paths are about your instance root directory, shared feature directory, and shared feature directory 32 bits. The best practices here is to install only the features that you need, and don't worry, if you need another feature, you can add it afterwards by running again the installation of SQL Server and selecting to add a new feature, as well as know that C drive, the OS drive, actually can be used for the above paths. And note that I'm talking about the instance root directory, shared feature directory, and shared feature directory 32-bit. Now about the instance configuration, you are presented with two options. You either select to install a default instance of SQL Server or a named instance. A default instance of SQL Server is when you want to be able to connect to SQL Server by only specifying the server name or IP, for example, server 1. A named instance is something different. By installing named instances of SQL Server, you can connect to the SQL Server instances by specifying the server name or IP along with the instance name. For example, server 1, instance 1, and so on. Now, the best practice here is that if you will just be using one instance on the server, you can go with the default instance option. Otherwise, you can consider using named instances. Now, about the server configuration option during installation of SQL Server, you need to configure the service accounts for SQL Server Agent, SQL Server Database Engine, and SQL Server Browser. Now, the best practice here is to use domain names, not administrators, however, so you should never use a domain administrator as a service account for these services, and you use simple domain users that serve as service accounts for the Database Engine and Agent. Now, regarding the SQL Server Browser service, you can use local service as a service account. Then you are presented with the option to grant perform volume maintenance task privileges to SQL Server Database Engine service. This uses instant file initialization and allows for faster database creation. However, there is a potential security risk, and that is the possibility of having someone hacking into your server and possibly read the non-zeroed memory spaces and retrieve that data. So the best practice is to use this option only when SQL Server will be hosting large databases and only in the case where you took the adequate mitigation actions for the above security risk. Now about the database engine configuration, and more specifically server configuration, you need to select the authentication mode to use. So you can either select to use Windows authentication mode, which is recommended based on the security best practices, or mixed mode, that is SQL Server authentication and Windows authentication. When using Windows authentication, you can only log into SQL Server after, of course, you granted the appropriate access using Windows accounts, that is local Windows users or domain users if your SQL Server instance is on a domain. With mixed mode, you can use Windows users and domain users. However, you can also use users that you create on SQL Server itself, and that is users that use a username and a password. The best practice is to use Windows authentication mode because it's more secure, because the credentials are passed through Windows security. Now the next step is to specify SQL Server administrators, and here you have the option to add the current user or a user group, or you can use other users as well. During this step, you need to be very careful in order not to log yourself out. To this end, you need to make sure that you add at least one SQL Server administrator. The next step is to set up the data directories. So first you set the data root directory, then you get the system database directory. This is a read-only field. It inherits from the data root directory specified before. So for the data root directory, it is where the system databases of SQL Server, and that is master, MSDB, and model, will be hosted. So never use the OS drive for this directory. Always use another drive that is available on the server, which can be also expanded in the future in case it is required. Then regarding the user database directory, user database log directory, and backup directory, the best practices for data directories, it is to use separate physical disk pools for database data and log files. And you need to do that in order to have parallelism. So this will allow SQL Server to access in parallel your database data and log files. Also, it is recommended to use separate physical disk pools for TempDB data and log files as well, because TempDB is a special system database in SQL Server that can contribute towards performance. So it is really up to you how you set up TempDB in order to contribute positively to SQL Server performance. Now, let's talk more about the TempDB setup process during installation, and more specifically during database engine configuration. So, for the data files, you need to specify the number of files, the initial size in megabytes, auto-growth settings, again in megabytes, and then data and directories. Now, the best practices is to use the same number of TempDB files as the number of logical processors, up to 8 logical CPUs. Now, if your server has more than 8 logical CPUs, do not add more data files for TempDB unless you observe contention. So in case you have more than 8 logical CPUs, you start with 8 TempDB data files and you observe if you have contention. If you have contention, you can consider adding more data files for TempDB. At this point, note that during this installation step, SQL Server counts the logical processors on the server and recommends the number of data files that you should use. Now, regarding the TempDB log files configuration, you need to set the initial size and auto-growth again, like you did in the data files, and the log directory. So another best practice at this point for TempDB, as mentioned earlier as well, is to use 2 dedicated disks for TempDB data and log files in order to have parallelism when SQL Server accesses these files. Now, the next step in SQL Server installation is to set the Maxtop. Maxtop stands for Maximum Degree of Parallelism and configures SQL Server so that SQL Server knows how to distribute a request for parallel execution against the available logical CPUs. Now, SQL Server Installation Wizard, since the SQL Server 2016 version, recommends the Maxtop value to be based on the available NUMA nodes on the server, based on a given formula which you can find online on MS-DOCS. Now, the best practices is to usually use the recommended Maxtop value, so that's okay. And if you add more NUMA nodes in the future, you might need to revise this value. Now, the next step is to configure memory, that is RAM. So you need to configure the minimum and maximum RAM amounts for your SQL Server installation, and there is an automated recommendation given, again, based on the available RAM resources on the server. The best practices here is to make sure that you leave an adequate amount of RAM for the OS, so never allocate all RAM to your SQL Server instance, but leave also an adequate amount of RAM for the OS in order to be able to function properly. And if you add more RAM in the future on the server, you will need to revise this value. So you need to remember to revisit this configuration setting in case you add more RAM to the server. Now about the file stream, use only if required. And now there are some post-installation steps that should always follow after installation of a SQL Server instance. So first you need to configure the model system database, because whatever settings you apply on this special system and database of SQL Server are inherited to each new database you create on the specific SQL Server instance. So for example, if you set up the recovery mode, the initial size and autogrowth settings for data and log files, and so on, all these will be inherited automatically to new databases that you create on the SQL Server instance. Another post-installation configuration step is to confirm that you capture at least the failed login attempts in your SQL Server instance. So if it is not enabled, you are advised to enable the failed login auditing in the SQL Server security settings. And also you can consider at this point to capture successful logins, not only failed logins. Of course, doing so will also require more disk space, because the logs will be significantly larger than the ones that contain only the failed logins. Moreover, it is recommended to enable TCP/IP and change the default port from 1433 to another high port range, and also read the MS-DOCS article for SQL Server Security and take the relevant actions. You can follow this link in order to read this very useful MS-DOCS article. This video is part of my online course, Essential SQL Server Administration Tips. Check the video description for enrolling to the course with a major discount. Thank you for watching this video.